investigate something, then we have to run this hypothesis testing. And there are several types of hypothesis testing. We have 1 sample mean, 2 sample mean, so on and so forth, right? So in this chapter, GT 555, there are 5 hypotheses that we want to look at all together. And today, this is the first hypothesis, 1 sample mean. Okay, kira kita guna hypothesis type yang mana satu, then you have to go through these 5 steps, these 4 steps. So step 1, you need to construct the hypothesis. You have to put the null hypothesis and alternative hypothesis. For null hypothesis, usually it is about the normally about the standard that have set previously, right? Or it is based on the accepted value for the present or currently accepted value. Whereas for the alternative hypothesis, this is the statement that you want to investigate. Apa yang kita nak investigate, apa yang kita nak buat research tu, kita letak statement dekat alternative hypothesis. So there are 3 ways, there are 3 scenarios. If you have the first scenario of the hypothesis testing, you see your mu is greater than 0. So if you draw the normal distribution, you will have one tail to the right of the distribution. If you have the second hypothesis, right? So your mu is less than 0. That means if you draw the this is the normal distribution. So you find that you also have one tail, but this tail is to the left of the distribution, right? And then you have the mu not equals to 0. That means the distribution can be either on the left side or the right hand side. That means you have 2 tails in the distribution, right? And when we want to run the hypothesis testing, there is tendency of having type 1 error. Right? I hope you still remember what is type 1 error. So that is the tendency of making we reject the null hypothesis while it is true, right? So in order to overcome this situation, we have to consider the significance level. Significance level adalah the chances of making type 1 error. So for this type 1 error atau alpha, you can set it at 1% ke, 5% or 10%. Let's say if you have by default lah kalau soalan tak bagi tahu kan. So we set it at 5%. So let's say if you have 5% significance level, so that means your type 1 error is only up to 5% saja. So the remaining 95% that you are sure type 1 error can be reduced, right? So that is the thing that you need to consider. So looking at the when you construct the hypothesis, can so if you have 5% significance level atau your type 1 error, if you have the situation 1, can so the tail is on the right of the distribution. So this shaded area is 5%, right? So your significance level is 5%, right? And the rest will be 95%. Okay, on the second scenario, also 5% in this shaded area. And this shaded area, and even kita panggil, we call this as, do you remember what is the term that we use? Okay, so this part, bagian ini, it is rejection region, right? Rejection region. And this area is non-rejection region. Or sometimes you'll find that in the textbook, you have the acceptance region, right? Okay, same goes to this second scenario. Ini adalah rejection region, maksudnya reject HO lah, ya. Non-rejection region, so do not reject HO over here, right? So this is non-rejection region. And this is rejection region. So reject apa? Reject HO. Right? Rejection region. Kawasan yang kita buat rejection. Okay. Now, when you have the third scenario where you have the two-tailed index distribution, let's say you set your alpha equals to 5%, right? And you are 95% confident that the type 1 error can be reduced. And you know that this normal distribution under the curve, the probability is equal to 1, right? And why we have 0 here? Because it is symmetry about the mean. Yang ni adalah mean tengah. So if you go into half, then this side will be 0.5, the other side will be 0.5. So since this is, we have this alpha, yeah, at 5%, so kita ada 95% confidence that tak akan berlaku atau type 1 error boleh dikurangkan. Jadi yang selebihnya adalah 0.05. And because you have two tails in the distribution, 5% too, you're going to divide by 2, right? So this on the left tail, on the right tail, you have equally divided of 5% by 2, right? Then the probability atau the shaded area is 0.025, right? On the left hand side and on the right hand side. Okay, so that is step 2. Yeah. And then next we want to use the approach. We want to make a decision, right? You can have p-value approach and also critical value approach. So if you are using p-value approach, right, then you just need to look at p-value and alpha, right? Okay, if yang ni sama dengan yang statistical method, sama dengan yang econometrics lah. Kalau p-value is greater than alpha, so your decision is do not reject HO. And the other way around, if your p-value is smaller than alpha, then you can make a decision to reject HO, right? However, if you use this critical value approach, right, the criteria are different already. Yeah, is already different. So I would advise you to look at this properly and don't mix up. Yeah. So ada juga macam student yang dia guna p-value approach tapi dia compare p-value dengan critical value, right? Atau dia guna p-value compare dengan test statistic. Atau dia guna critical value compare dengan alpha, right? So I hope this won't happen in this semester. Yeah. Okay, for critical value, you have to compare critical value and test statistic. Usually we have to calculate the test statistic, yeah, and then critical value. But this time, when we have the one sample hypothesis testing, we can do it manually. We can calculate it by using the formula, and we need to key in this in Excel. But starting from 2 sample hypothesis onward, you can use the analysis toolbar to calculate, and then you don't have to do anything. With a few clicks, you will get the result, you will get the output. You just need to know how to interpret it. Yeah, so we'll look at that when we are in 2 sample mean. So sekarang ni for 1 sample, kita kena buat secara manual. Okay, after you have as to what approaches to use, kan? So you have to look at the question. Sorry, kalau tak ada question tak mention, you can use p-value approach sebab yang ni paling senang, right? Okay, then step number 4 is you need to draw a conclusion, right? You know that when we test hypothesis, kan, we base on the sample data to conclude the population's scenario, right? So based on sample data, you got decision. After decision, then you conclude, right? Remember, we have this example, right? Because the population is too large, right? We can't. We have constraints in terms of the time, in terms of the budget, and then of other factors as well. So we cannot collect all the population's data. So we need to get the sample. Bila nak dapatkan sample, this sample must be representative. Yes, when you come out with the decision adalah based on the sample data, and then we will kind of making the conclusion of the sample data for the population, right? That's why this sample must be representative. Otherwise, the output, the findings will be not reliable. So any questions on this? So kita dah macam recall apa yang kita belajar. Yang ni adalah secara konsepnya, and you have to apply this concept. But I think I don't think economic students ada masalah sebab you have gone through this. You have learned the statistical method before, and then you have come across this various hypothesis testing, and then you met this hypothesis again when you were in part 4, right? When you have this econometrics. So sekarang part 5, so you ada business analytics, benda yang sama. Right? Cuma kaedah berbeza. When you have this statistical method, you use SPSS to analyze. Bila you are in econometric subject, you guna e-views. So now you are in this subject, business analytics, we use another method. So kita guna Excel. So sekarang you dah tahu ada 3 kaedah yang boleh kita run hypothesis. Okay, so let's look at the okay, so this is just want to highlight to you again what is this hypothesis testing, kan, atau we call that as statistical inference. So that means this one statistical inference focuses on drawing conclusion. Kita nak buat keputusan about population from samples. So based on sample data, kita buat conclusion for the population, right? So yang ni adalah maksudnya hypothesis testing atau statistical inference. Okay, so we have this hypothesis, type 1, type 2 error, and these are the steps that you need to use. Kita panggil sebagai procedures, right? And then these are the 3 scenarios that you have for the hypothesis testing. And then next is we want to look at this scenario. Okay, so I hope every one of you have already stand by with the cuts off. So you have got ready this cuts off data set. Okay, for this cuts off data set, you have this scenario. It's cuts off receives calls for technical support. So in the past, the average response time has been at least 25 minutes. So in the past tu, maksudnya this is based on the currently accepted value kan, atau the standard, right? So in the past, the average response time has been at least 25 minutes. So at least I hope you know how to apply this simple. At least tu maksudnya sekurang-kurang, right? Greater than or equal to. So this is at least, right? And then what is at least? That is the average response time. So this is your X bar, right? Okay, so this statement, untuk statement ni kita kena letak dekat hypothesis. Apa ni? Alternative or null hypothesis. Okay, look at the second statement. It believes that the average response time can be reduced to less than 25. So yang ni kita tak tahu lagi. But then we assume that, right? And because of this, we need to investigate. So kita kena buat investigation. And the statement that we want to investigate, the thing that we want to investigate, kita kena letak dekat alternative hypothesis, right? So the mean response time is less than 25 minutes. So this is the alternative hypothesis statement. Okay, and this one is the null hypothesis statement because based on the historical data, based on the standard, based on the currently accepted value, kita letak dekat null hypothesis. So are you okay so far? Boleh kan?
Yes, madam.
Boleh, madam.
Okay, madam.
Okay, thank you for the feedback. Now, okay, kita pergi ke cutoff. So please, yeah. Now you can get rid of this data. Okay, we have this cutoff technical support response time, right? And because this is the first time we are looking at this data set, so yeah, you see, you have 44 responses from the customer, and the second column shows the time taken. Yeah, the technician, yeah, taken this amount of time to respond to the customer. Okay, so from the scenario, we have this alternative and null hypothesis. Okay, so you have this mu, yeah, population mean is greater than or equal to 25, and alternative hypothesis, mu average mean dan average response time is less than 25. So yang ni adalah kita dapat daripada scenario kita punya PowerPoint, right? Okay, now, so we need to calculate these few things, yeah. So kita kena calculate first the mu. Mu is population mean. Yeah, you can get it from the scenario. It is 25 minutes, right? You just write 25 minutes. Okay, and then next kita nak cari average response time. Okay, why we want to look at all this components, yeah. Kenapa ya? Okay, now take a look at this. You have this for this one sample mean, right? For one sample mean, you need to calculate the test statistic, right? And then compare with critical value if you are using the critical value approach. So kalau kita nak cari test statistic, so you need this formula, right? You have to check whether you have the sigma known atau sigma unknown. If the sigma known, so you use the Z test statistic. If the sigma is unknown, so kita guna yang T test statistic. So let's assume that we have unknown standard deviation, right? Yeah, we have unknown standard deviation. Okay, so kita akan guna T test statistic. So you look at the components in the T test statistic. For the numerator, you're gonna add an X bar, right? The average, the sample of the population, right? And then minus dengan yang ni adalah null hypothesis, and then divide by standard deviation, and divide again with the square root of n. So yang ni lah benda yang kita nak cari, ya. So maybe I can copy this, or I just so that is the formula. Maybe you can write the formula somewhere. So for example, you know, the T test statistic, right, equals to X bar minus mu, right, divide by the S, and then divide again with square root of n, right? So this is your t-test statistic. Okay, now yeah. So in order to substitute all the values and in this formula, so we have to calculate. This is your mu, right? This is your mu, and this is the average response time, the X bar. This is standard deviation S, because this is sample standard deviation kan, so kita guna S symbol, and square root of n, and kita kena square root kan dia. So semua ni kita substitute dalam form, right? So kita kena calculate one by one. Okay, average response time sama dengan biasa when we have data in chapter 2, kan? So we want to calculate the average. So you need to type average. Now, this is chapter 4. Okay. So average, what average you want to get? Excuse me. So average for the response time, right? So you just select some more. So you just select some more, and then from B4 to B27, and then you just enter, and then you get the average response time equals to 21.9. Yeah. And for standard deviation, yang ni kita dah belajar in chapter 4, kan? So you just type STDEV, right? And this is sample data. You just ambil yang bawah ni. And then again, you select the range. So you ambil range 2. And then I got here 19.4862. Probably you have a lot of the decimal places, right? And then you can reduce it into 4 digits. And for this square root of n, in Excel, you just type something like that. Square root is SQRT. Yeah, SQRT. So this is square root, right? You ambil yang ni. And then you need to put in the number, one number. You need to calculate the n, kan? Yeah, before that, we have to calculate n. So you based on this customer, right? Customer, you have 1 customer to 44 customers. So in this sample, there are 44 customers. So you put in the number. Yeah. So you enter. Or you can select this n, right? And another way, yeah, for your n. So say, for example, your n is 44. So to get the square root, SQRT, and the open bracket, you will select yang ni juga. So you get the same value, right? Either way. Either you, first you determine the count of the customer. So yang ni N44. Atau to get the square root, you boleh masukkan terus 44. Or you have this H8 dekat sini. Sudah boleh, ya. Okay, so far are you okay? Are you with me, class? Okay, thank you.
Yes, okay.
Okay, thank you. Okay, next. So you see all the we have all these values, right? And we can substitute this in the formula to get test statistic value, right? So yang ni kita buat manual lah. We start with the numerator, yang atas ni kan numerator. So you're gonna ada sama dengan open bracket, right? So you key in your x bar first, atau kita cari yang x bar. So this is the x bar, right? I just click the x bar value, dia punya cell, and then I go to minus with mu, right? Minus with mu. You can look at the mu based on the historical data, right? The mu is 25. Click yang ni. Okay? Kalau you nak type 25 pun boleh. Okay, so we have substitute the two values in the numerator. Okay, next adalah denominator. Bagi kan, so you're gonna divide by. So open bracket. Sebab dalam ni bukan satu value nya, dia ada dia kena divide by something else, right? So you divide and then open bracket. So you look for S standard deviation kan. So this is a standard deviation. Okay, and this standard deviation divide with square root of n. Divide dengan ini lagi. Okay, then only you close the bracket. Bracket class, and then semua dah masuk, you just enter, and your t-test statistic is negative 1.0522. Do you get the same?
Yes, madam.
Okay, Good. Okay, so we have got the test statistic equals to negative 1.0522. Okay, then your alpha, kalau dah kat sini, mungkin soalan ni dia dah set kan? Yeah, the alpha is 0.05, right? 5%. Yeah. Okay. Now, so step 1, we have construct the hypothesis testing. Step 2, we have determined the alpha, yeah, significance level equal to 5%. And then step 3, we need to use the decision to come up with the decision. So kita boleh guna either p-value approach or critical value approach, right? So if I use the p-value, we start with critical value, yeah. If I use the critical value approach, right? So I need to calculate my critical value. Then only I can compare with the test statistic. So for t, critical value of t, right? Now you have to check whether you have one tail or two tail in the distribution. So kalau kita lihat sini kan, right? If I were to draw the distribution, so I have this, right? And then symmetry about the mean, and then you look at the alternative hypothesis, their punya sign is less than that. So you have the left tail, yeah. So you have, there is only one tail in the distribution, right? At the left tail. Okay, so if you have one tail, yeah, this is the formula, yeah. Let me write down. I put it somewhere dekat sini. Of course, you have to put sama dengan, ya. Yang ni saya tak tulis sama dulu. I just give you the function. If you have one tail, yeah, you want to look for the critical value of t. So you're going to type sama dengan t dot inv, yeah, 1 minus alpha, and alpha, yeah. I just write alpha. Okay, 1 minus alpha, comma, and then n minus 1. So this is a function, yeah, critical t-test, dia punya function. Okay, now let's do it together. Okay, 1 minus alpha, alpha is 5%, n is 44 minus 1. Okay, kita dah ada semua value dah ada. Then I just need to type here. Okay, you're gonna type t dot I, you start with equal sign, yeah? So t dot I and v, right? And then you open bracket, you say dah ada kan? Okay, if you have two tail, kalau two tail, right? If you have not equal sign, ada two tail, so you have to use t dot inv two tail, right? But now because we only have one tail in the distribution, right? So kita guna yang pertama. We just double click yang ni, and then the question asks for the probability. So untuk dapatkan probability, kita kena ambil satu tolak dengan alpha, right? So 1 minus alpha. Okay, let me check first, yeah. 1 minus alpha, 1 minus 0.05. So you get 0.95, right? This is your probability. And degree of freedom is n minus 1. N minus 1 is your degree of freedom. So 44 minus 1. So you have 43. Okay, so you close the bracket and then you can enter it. So you enter and then you got 1.6811. Is everyone okay?
Okay, madam.
Okay, thank you for the feedback. Yeah. Okay. So this is your formula. So that statistic function, yeah. So you substitute in this, and then you get your critical value. Now you see, so kita sekarang ni dah ada support value, right? We have this value. Your test statistic 1.68. Your t-test statistic critical test statistic 1.8, 1.68. Your test statistic negative 1.05. Okay, to make decision, okay, maybe I can pindah ke bawah sikit. To make this decision, you compare, yeah, if you are using the critical value approach, right? So when we want to use the critical value approach, and this part starting from this part kan. So this is critical value approach. Okay, so you compare your t-test statistic, your test statistic, to compare with critical value, right? So your critical value is 1.6811. Your test statistic is negative 1.0522. Ingat lagi yang kalau ada negatif kan, so you ambil modulus absolute value, right? And then bila dah absolute value, or more negative, right? You still find that your critical value is larger than test statistic. So critical value lebih besar daripada test statistic. So yang ni kita kena ambil modulus, kena absolute value. And then your decision, if you based on the critical value approach, decision is do not reject H2. Right? Okay. So step 1, you have your hypothesis. Step 2, your alpha. Step 3, you calculate this and make decision. Do not reject HO. And lastly, your conclusion. Right? So what is the conclusion you can make? You can say that there is insufficient evidence to support the alternative hypothesis. Right? And because of this, the conclusion is the mu, the average response time, right, is greater than or equal to 25 minutes. Or the average response time is at least 25 minutes. Right? Sebab kita tak ada bukti yang cukup untuk menyatakan the average response time is less than 25 minutes. So if this is the case, then you as the manager, you have to check what happened during the process. And then if possible, so the process need to be reduced so that the average response time to the tak ambil lebih daripada 25 minutes. Yeah, this is how we do it. Yeah, how we use the hypothesis testing yang keputusan kan untuk buat decision. Okay, are you okay? I give you maybe a few minutes, 2 minutes to understand yang to recall lah yang apa critical value approach, and later on kita nak lihat yang p-value approach, right? Okay, yang t-test ni saya dah tuliskan. So this one is sama dengan, right? Okay, 2 minutes for you to digest this one. Kalau you faham yang ini, so the rest of the hypothesis testing tak ada masalah. Make sure you understanding me, yeah.
Madam,
yeah.
can you give the conclusion again?
Okay, conclusion is decision is do not reject each organ. So you can say that there is insufficient evidence to support the alternative hypothesis. So kita tak ada bukti yang cukup untuk support alternative hypothesis, right? Okay, I repeat, there is insufficient evidence to support the alternative hypothesis. Therefore, it can be concluded that average response time is at least 25 minutes. So, maksudnya kita tak ada bukti yang cukup untuk nak support alternative hypothesis, maka kita kena buat keputusan atau kita buat kita buat conclusion based on the null hypothesis, right? So kita tak ada bukti yang cukup untuk support sebab kita punya decision do not reject HO kan. Jadi kita kena buat conclusion based on the null hypothesis. Boleh ke?
Okay, madam.
Yeah. Okay. Okay, another 1 minute for you to digest critical value approach. Okay, untuk yang ni kan kita we have to learn two approaches lah, because sometimes you have to use the critical value, sometimes you need to use p-value, or you want to use both to reconfirm your decision, right? Kita kena tahu dua-dua kaedah. Yeah, I hope you have an idea. Yeah, you have already understand the critical value approach. Yeah? So now we go to the p-value approach. So p-value approach too, you have to compare the alpha with p-value, right? So di sini, saya highlight di sini, use the p-value approach, right? So yang ni adalah critical value approach. So maksudnya step masih sama. You boleh check the step dekat sini kan. First, you construct hypothesis. Second, you decide on the significance level. Not to say decide lah, you look at the question kan. So question will tell you, otherwise you take this 5% as default. And then you make your decision using critical value atau p-value, right? And then conclusion. Okay, so yang ni pun sama juga. Okay, for p-value approach pun sama. Step 1 is construct hypothesis. Step 2, you look at the alpha. So alpha di sini adalah 5%. So you type 5%. Okay, as for p-value, dia ada function dia juga, right? For p-value. Okay. If you have the one-tail test, yeah? If you have one-tail test and the tail is to the left, yeah, of the test statistic, kalau tail dia punya tail adalah on the left-hand side, then you should use this formula. You use this function, yeah. So you type t dot dist open bracket t degree of freedom n minus 1, and yang ni dia punya rule, you kena tulis macam, right? Kalau if you have the p-value, that statistic, and the tail is on the right side, right? So you kena guna yang ini, 1 minus this whole thing. Satu tolak dengan sini. Okay. Later on I can write it. Okay. If you have two tails, right? If you have two tails in the distribution, you can use this t dot dist dot to tail, open bracket, t minus t comma degree of freedom n minus 1. Yeah, you don't have to write in capital lah, cuma saya tadi activate saya punya capital button. Okay, and then this is another one for two tail. 2t, open bracket, so you have this negative. Okay. Right, so you have this for p-value ada beberapa function lah, but you have to choose which one is suitable to be used in your analysis. Okay, yang pertama, this is p-value and with left tail. This is left tail. If you have left tail test, yeah, left tail test. If you have the right tail test, you use this 1 minus t dot dist, right? So open bracket, t, comma, degree of freedom, comma, true. Kalau ada right tail test. And these two adalah two tail. If you have two tail tests, right? You're gonna either one of this. Misalnya kita nak tahu which one is for two tail. If your t, you dapat positive value, so you ambil yang pertama. If the t is in negative value, so you ambil yang kedua. For example lah, yang ni adalah two tail, right? So your t test statistic keluar negative. So you should use the second two tail test function. Yeah, yang ni dia punya criteria for the p-value function in Excel. Okay, we look at our scenario. We have this tail test, one tail to the left, right? So kita ada left tail. So if you have the left tail, so you're gonna type yang ini lah. So you use this one. Okay, so function gonna start dengan sama dengan. So you type t dot dist, right? Belum kita habis, so dia dah ada kan, whether you have one tail atau right, one tail atau two tail. So this is one tail, and I just check this one tail. Double click yang ini, and next you see x timbul kan, x stands out. So you're gonna masukkan value of x. So this x is your t. I think this is your t, yeah? Your t value. So your t value is this one. So you just click dekat sini. Your t value. You click this t, right? Yeah. And then comma, degree of freedom. So n minus 1, masih lagi 43. And then, so you're gonna type true, right? After you comma, after you put in the degree of freedom, you comma, then you can type true. Yani memang dah formula here, right? So you double click and then you enter. And then I got this 0.1493, right? You dapat 0.1493. So this is the function. I have one tail to the left kan, so saya akan guna function yang pertama to get p-value. Boleh ke kelas?
Boleh, madam.
Okay, good. And then, yeah, so we have p-value and critical, we have p-value and alpha. We can make our decision, right? So decision, You can just write dekat sini. You write your p-value to compare with alpha. Jangan p-value with critical value atau p-value dengan test statistic. Okay, the components yang ada dalam p-value adalah dua ini saja. Ya, tak boleh tukar pasangan lah. So yang ni dah memang dah fix untuk dia. Ya. So 0.05 and then the p-value is 0.143. Okay, you compare these two, and p-value is larger. Kalau p-value lebih besar, your decision is do not reject. Right? Do not reject issue. Yang ni sama dengan statistik yang lain. Maksudnya, if your decision yang ni kan, critical value dengan p-value approach, dia kena consistent, right? Dia kena consistent. Do not reject yang ni untuk p-value approach. Dengan critical value, kena do not reject juga. Dia punya decision mesti consistent. Tak boleh satu reject, satu do not reject. Okay, so yang untuk p-value sama jugalah. Yeah, you need to make a conclusion. So you can say that there is insufficient evidence to support the alternative hypothesis at 5% significance level. Therefore, it can be concluded that the average waiting time is at least 35. Average waiting time is at least 25 minutes. Okay, so yeah, you need it. Yeah. Kalau decision, I repeat, if your decision is to not reject HO, then you need to conclude based on the null hypothesis. Yeah. Okay, now kita lihat yang ini. Yeah. So you see, sekarang ni kita punya p-value do not reject, critical value do not reject. So kalau kita nak lihat yang, I need to make it smaller so that we can look at one shot, kan, everything at one shot. Okay, let's say this is our distribution, right? And this is your test statistic. This is your critical value, 1.6811. Okay, and it is on the left of the mean, so dia akan ada negative. Okay, and then your test statistic, nampak kan? Yeah, right, clear. So negative 1.688. Okay, so this is your critical value. Kita dapat 1.688. Okay, and because it is on the left of the mean, so you should put the negative value. And then next, let's check what is the test statistic. Kita punya test statistic is negative 1.05. So 0 kan dekat sini, negative 1.05 somewhere dekat sini, right? So this is negative 1.05. So your t-test, your test statistic falls in non-rejection region. So excuse me, dia masuk dekat non-rejection region. So you see, you compare tiga benda ni. Satu menggunakan graph, do not reject HO. You guna critical value, decision do not reject HO. You guna p-value, decision juga do not reject HO. Yeah. So semua adalah consistent. So inilah cara kita buat keputusan, right? Based on kita punya hypothesis testing. Boleh ke kelas?
Boleh, madam.
Okay. Okay, good. So I give you 2 minutes. 2 minutes, yeah. 2 minutes to digest this, and then we'll look at another data set called fast food. Yeah. Cuba get ready yang this one. fast food restaurant customer waiting time, right? Okay, so kita lihat yang ni. You try to digest this one. Okay, class, are you ready?
Yes, madam.
Okay, thank you. Now, you see, okay, this is our data set, right? Fast food restaurant customer waiting time. You have 50 customers, and these are the waiting time, their waiting time recorded, right, in the fast food restaurant. And the scenario, this is the scenario. So the normal time taken by a fast food restaurant in serving the customer is greater than 8 minutes after placing an order. So the manager of the restaurant would like to investigate if the waiting time is less than 8 minutes. Okay, so this is the statement you need to put in the alternative hypothesis. Right, kita nak investigate kan. Okay, the manager collected a sample of 50 customers waiting time as shown in the data set. So at 5% significance level, so dia dah bagikan 5% significance level using critical value and p-value approach to hypothesize if there is evidence that the sample mean waiting time to place an order support the claim made by the restaurant. Right. Yeah. So biasanya dia akan bagi scenario macam. And then for the for null hypothesis, so you can letak greater than equal to 8 minutes. Right. This is 8 minutes. Okay. And then, yeah, so if you draw the distribution, this will be on the left-hand side of the tail, right? The tail is on the left-hand side. Okay, critical value approach, right? So you masukkan value di sini. So this is 5%. Okay, mu is 8. So average waiting time, kita kena calculate. Average. Okay. So you just masukkan the time. And then kita ada standard deviation pun sama. So STDEV dot S. So you open bracket. You select semua ini. Okay. Yeah. And then N is 50, right? Tadi N 50, right? So now you need to square root SQRT, square root the N dekat sini. So you need to square root it. So you dapat 7.70. Okay? Yeah. Semua dapat ni kan? And then for the t-test, you're going to calculate lah t-test statistic. So open bracket, so you're going to have the average response time, tolak dengan mu, right? So close the bracket, divide by S, this is S. Divide lagi, yeah, this one you need to open the bracket. So ini, this is your S, and the division, divide by the square root of N. So barulah ni. And you got this negative 0.2. This is the formula. Yeah. So untuk critical value macam yang tadi lah, right? So for critical value, you only have one tail, so you guna yang ini. So T dot INV. Okay. So this, sorry, T dot INV. So you have one tail, and then the probability 1 minus alpha, so still 0.95. And degree of freedom sekarang 50 minus 1, right? 50 minus 1, so you have 49. Okay, so this is your critical test statistic. Critical test statistic 1.67. Okay, now you compare your test statistic with the critical. So you absolute value this one, and you still found out that the test statistic is smaller than the critical value. Therefore, the decision di sini adalah do not reject HO. Right? You need to not reject HO. And then for p-value, some p-value approach. Yeah? For p-value approach, here you have also left tail, right? So let me sama dengan left tail p-value. So the formula is T dot DIST. Open bracket. Right? Ada one tail saja. So your x is this x, okay? And then comma, degree of freedom is 49. And so you can letak true, right? So you close the bracket. Your p-value is 0.4, 0.42. So 0.42 is larger than alpha. So decision also do not reject it. Yeah? So any do not. So this decision also the same for the critical value approach. Do not reject it. Yeah, that's boleh kan? Make sense or not?
Boleh je.
Okay, good to hear that. Okay, I want to show, Yani, I'll give you 1 minute. I want to give you the scenario where you have, let's say you have the sign equal to, macam mana kita nak buat. Okay, I have 1 minute for you to understand this first. Okay, for this hypothesis, you akan ada your curve. Okay, so it is less than kan, the other less than, so it should be on the left hand side. So this is your alpha. Okay, yeah. So you guna cara yang biasa. What if, kalau saya bagi contoh lah, right? Scenario kita abaikan scenario ini. Kalaulah if you have this, right? Your null hypothesis mu is equals to 8. Alternative hypothesis mu is not equal to 8. So now you have two tail in the distribution, other dual tail, right? It is alpha divided by 2, alpha divided by 2. Okay, so if you use the first step construct hypothesis, second step you look at the significance level. Step yang ketiga, if you use the critical value, right, versus the test statistic. Say for example, kita dah calculate test statistic, test statistic is negative 0.2043, but you need to calculate your critical value, right? For critical value, if you have two tail, macam mana ya tadi? If you have two tail, kan? For p-value, so you just type equals t dot inv two tail, right? And then you open bracket, you masukkan alpha saja, 0.05, and degree of freedom 50 minus 1, right? So yang ni adalah your critical value, right? Two tail. Okay, let's calculate it. Let's do it together. So sama dengan t dot inv, right? So two tail, double click ni. Probability, so kita masukkan alpha saja. Kita masukkan alpha. You have this 5%, right? 5%. So you just need to key in 5%. And then degree of freedom 49. So you enter. And your test statistic, your critical value, right, of the test statistic is 2.0095. So kalau saya nampak ini banyak decimal places, I just need to reduce it to 3 digits, right? 3 digits. Okay? So this is the critical value. Critical value. So the formula is this. Yeah, you guna this formula. Yeah. Okay, now you compare you have the test statistic. This is your t-test statistic, negative, based on this in 0.2043. So you compare these two, critical value is greater than the test statistic. Okay, so decision, do not reject H4. Yeah, do not reject H4. Okay, so this is when you have two tail. Okay, what about the p-value? Kalau kita nak guna p-value approach, so you kena guna, and for this p-value, the function is, if you two, let me write it again. For two tail, you can use, I did do again. You can use this one, t dot dist dot two tail, and then you're gonna t minus, sorry, t comma, we need to put in t and then degree of freedom. Okay, you use this if your t is greater than 0. Maksudnya your t is in positive value. If your t is less than 0, about negative, then you should use this t dot dist to tail. We're gonna negative t degree of freedom and minus 1. Right, so you're gonna. So in this case, kita punya test statistic. The test statistic is negative, right? So kita kena guna this function. We need to use this one. Okay. For the test statistic, kita dah done. We have done this. So kita calculate yang p-value. So to get this p-value, kita guna function yang kedua, t dot dist to tail, right? For this to tail, you masukkan negative, you key in negative, and then masukkan this value, you ambil value yang ini ada dekat masa kita buat contoh yang kedua, right? And then comma, your degree of freedom 49, and then you enter. So your p-value is 0.8389. And let me round up. Round up to 3 and 4 decimals. Okay, so dengan ini, your p-value compared with alpha. So alpha is 5%, p 0.8390. Okay, so your decision is do not reject. Do not reject H4. Okay, so both of the decisions are consistent. Dua-dua adalah consistent. Okay, if you want to look at it graphically, so kalau nak lihat secara graph, you can use this. Your critical value is how much? Yeah, critical value is 2.010. So you have two tail. So di sebelah sini negative 2.01. On the right hand side, you have positive 2.01. And the test statistic is negative 0.2. So we know that this is 0. So negative 0.2 is somewhere here. negative 0.2, right? So this is your test statistic. That means it falls in rejection, sorry, do not reject region, atau acceptance region, right? So consistent lah, yang ni do not reject HO, yang ni do not reject HO, and yang ini pun reject HO. Yeah. So depending on the scenario, and then you have to construct your hypothesis. So you tengoklah, dia adalah one tail to the left, one tail to the right, atau two tail, right? So you have several p-values function to choose from. So you're going to think. Okay, in this case, you can say that there is insufficient evidence to support the alternative hypothesis. Therefore, it can be concluded that the, what is this? The customer waiting time, yeah, is greater than 8 minutes. Yeah. So kita punya decision adalah do not HO, maka kita kena buat keputusan based on null hypothesis statement. I hope you are with me. Is everyone okay? I'll give you 1 minute to digest this one. Right. Okay. Good. And then I have a few past year questions, not to say past year, a few tutorial questions for you to answer. Right. So I give you 1 minute to digest this first, and then I'll show you the tutorial questions I have assigned to each group, tutorial group. Okay, boleh ada soalan Okay, for the tutorial, so you boleh lihat dekat sini tutorial. So hari ini 4 didn't turn up, yeah, 4 didn't come. Okay, so for tutorial, go to the tutorial group. So we have 2 questions, kan? Right, 2 questions. Yes. Oh, so you didn't put the tutorial questions here? Okay, so you see, I have assigned, kan? Yeah, you're gonna ambil lah someone, you have to take the question. There are 2 data set you need to look at. So kita ada vacation survey and consumer transportation. Okay. So we have consumer transportation. This data set. And satu lagi adalah no, not here. Vacation survey. Right. Okay, saya ada dua data set. Okay, satu adalah consumer transportation survey. So ada soalan, yeah, you just focus on the question yang atas ya, jangan ambil yang bawah. Bawah tu adalah 2 sampel, right? So based on this sample. So this is 2 sample. Ignore yang ni dulu. 2 sample ni. Okay. Okay. For 1 sample mean, you lihat A, B, C. Ya, ignore yang D ya, proportion. Proportionate kita tak lihat lah, kita lihat mean saja. And for vacation survey, yang ni lah soalan dia. Satu soalan saja. This is a question, right? Okay, I have assigned questions to, okay, so group 1, yang ni tutorial group, bukan group project. So your group project dekat sini. Kita belum lagi start group project, right? For tutorial group, okay, group 1 consists of Yana, Dia, and Karina. You all buat vacation survey. Okay, kumpulan 5, Zahir, Aidil dengan Miro, you all buat juga vacation survey, right? Saya tulis ni tarikh sebab hari tu ingat, boleh siap, boleh bagi, tapi kita you just ignore lah yang ni. Okay, kumpulan kedua, you buat consumer transportation survey question 1, right? Ismi, Azra, and Zuri. And kumpulan Jana, Eha, and Omar. Sorry, yang ni question number 2 already, yeah? Consumer transportation survey question 2. And then group 4, you buat consumer transportation survey question 3. You have this Husnaida, Atika, and Ayu. Okay, question 2 for consumer transportation survey, Mira, Faiza, and Maera. Okay, you all buat yang buat semua ni, and then you paste as usual lah. You screenshot your answer and paste it in one of this lah. Maybe you can choose. Okay, I assume the first one is the group leader. Kalau you rasa number 1 you don't want to be group leader, so you need to write bracket siapa jadi leader. So kalau tak ada, I assume that okay, the name, the first name here is the group leader. So for example lah di sini, we assume that Yana is me, Mira, Husmaira, Husmaida, Zakir, Jana. So these are the group leaders. So you all discuss, then the analyze jawapan, then you put your answer. So you screenshot your answer and letak dekat homework. So you type lah chapter 5, 1 sample mean. So you paste your answer there. So kita akan discuss yang ini dekat tutorial. Yeah, dekat tutorial. I mean 1 week from now, but you need to, if possible, you try to finish up this week, because next week maths lecture kita nak buat 2 sample lah. So make sure you kena faham yang. And during maths lecture, saya cuma bagi lecture saja, because ada banyak group kan, so I cannot. Yeah, kalau saya lihat group 1 dan another group saya tak lihat, macam tak fair gitu, right? So I have to wait until the tutorial class, baru saya akan lihat setiap group your punya tutorial answer, right? So you buat and then letak dekat homework, and then you create a page name chapter 5, 1 sample. Is that clear, class?
Ya, madam.
Yes, madam.
Okay, so you jangan bagi file dulu ya. Yang ni tak perlu bagi file. So you just screenshot your answer and then letak dekat the page. Yeah, your page. Okay, I think that's all for today. Do you have any questions? Any questions to ask before we end the meeting today?
Not for now, madam.
Okay, thank you, Mira, for the response. Okay, thank you, Adil. Okay, kalau tak ada, then yeah, you can work on the tutorial question and then can paste the answers there, right? You have half an hour to do. Okay, and then I see you again. Bye. Take care, everyone. See you next week.
Madam,
Yeah,
cuba
okay.
cek apa tu note saya dah ada.
Ideal yang kejap your tutorial.
Ya,
Okay, kejap yang this one. Homework. Betul kan Ideal? So chapter 2.
okay, ada.
So chapter 3 yang ada. Chapter 4 yang ada. So this is your screenshot kan? Yang ni nampak jelas. So yang ni idea you buat macam ni bagus lah sebab you boleh buat revision kan, you tahu apa. You boleh keep track apa yang kita buat dalam kelas. Right? Sebab setiap each one of you akan ada notebook sendiri kan dekat Microsoft Teams ni. So you boleh buat semua ni untuk diri sendiri dan next time you nak buat revision senang. Yeah. Okay, thank you Ideal.
Thank you, Adam.
Okay. Thank you. Okay, bye.